So now we move on to a discussion about domains of tangent and cotangent functions and what could we expect from those. Well, the first question, why are the domains of tangent and cotangent functions restricted, is actually a relatively straightforward one to answer. And it's a very similar reason to the ones for our secant and cosecant functions having restricted domains. That is that specifically tangent of x is the function that is formed by taking a ratio, right, our ratio identity of sine of x and dividing it by the cosine of x. So what that implies is that we cannot include in the domain any values of x for which cosine of x is equal to 0. So if we know where those values are, we know where the tangent domain is restricted. Similarly for cotangent, cotangent of x is a ratio of cosine of x divided by sine of x. So in a similar way to what happens with cosecant of x, sine of x is in the denominator, and of course we would imply here that anywhere where sine of x is equal to 0 will be outside of the domain, and so any place where sine of x is equal to 0 has to be excluded from the domain there. So we ask, well, what is the domain of tangent of x? Well, again, let's look at the function cosine of x, since we're interested in what's going to happen right there. And as we recall, when discussing secant, 0, pi over 2, pi, 3 pi over 2, and 2 pi are all key points within one cycle where cosine goes 1, 0, 1, negative 1, then 0, and then 1. So what's going to happen for tangent of x? Well, any place where cosine of x has a 0 is going to be undefined, and that means for us odd multiples of pi over 2. So recalling what we said, that if x cannot equal the odd multiples of pi over 2, we said that our way of stating odd multiples of was to say 2n plus 1 multiples, where n is an integer. And so our domain for tangent of x will be the set of all x values such that x is not equal to 2n plus 1 multiples of pi over 2, where n is an integer. Okay. What about the range? Well, the range of a tangent function is going to be the set of all real numbers. Now, why all real numbers? Well, in fact, unlike sine, cosine, and even secant and cosecant, there is no limitation on the tangent graph. And of course, that implies, again, there is no amplitude, right? Just like there was no amplitude for secant and cosecant, there's no amplitude here. All right, let's talk about the similar idea about cotangent of x. What do we know about cotangent of x? Well, if we recall what happened with sine of x, we can get a good idea. Sine of x was the kind of function in which at one key point, at the key points within one cycle, 0, let's see, we had pi over 2, pi, 3 pi over 2, and 2 pi. We would have had 0, 1, 0, negative 1, and then 0 again. These are points at which we're going to get undefined values for the cotangent of x. And so if we're looking for our domain of cotangent of x, we had found that x could not equal multiples of pi, just any multiple of pi, whole number multiples of pi. And our way of stating that, if we're going to exclude these values from our domain, is to state that the domain of cotangent of x will be the set of all x such that x does not equal n times pi where n is in the set of integers. And like tangent, the cotangent range is also all real numbers. Again, it has no amplitude.